To our meeting room, we will continue our study. Thank you very much. Okay, we will continue our study about the work and energy. Okay, thank you. You see, the principle of work and energy is easy to apply, right? Yeah, it depends. If you can calculate the energy, the kinetic energy correctly, you can calculate the work correctly, it will be easy. But sometimes if you don't know how to calculate the kinetic energy, how to calculate the work by the forces, by the moment, yeah, it will be difficult. Anyhow, okay, we will continue to apply the principle of work and energy. Whichever of mass m and length l is released. What's wrong? From rest in the horizontal position. Here we got a very important is released from rest in the horizontal position. What is the water's angular velocity when it has rotated through 90 degrees? Okay, I forgot to here for this question. We already found out the velocity. Have you ever think about how to find out the acceleration or the angular acceleration? Is it okay to find out the angular acceleration? If we need to find out the angular acceleration, we need to find out the acceleration of the mass center, right? If we already also know the acceleration of the mass center, is it possible we can find the angular acceleration? Definitely, we can find the angular acceleration, right? Because the acceleration of the mass center is equal to r times alpha, right? But is it okay to find out the alpha or a? Here, we don't know. We only know the velocity. Is that possible? Here, is that possible we can apply equations of motions? If we can apply equations of motions, what will be? This will be the FBD and then MAG, right? And IG alpha, right? IG alpha should be this one or this one. It should be counterclockwise or clockwise. MAG, right? This is FBD. And I use red arrows to indicate the KD. So MAG, right? AG for the mass center horizontal, right? Because the displacement or the distance of the mass center to the contact point always equal to the radius. So the acceleration of the mass center should always be horizontal. And if I indicate MAG to the left, so what will be IG? IG alpha will be this one, right? Because it rotates. Okay, so IG alpha. So according to the equations of motions, we will have sigma F equal to MAG, right? So Fx we define to the left as positive. Okay, so Fs minus Fb equal to MAG, right? Fs equal to Fb equal to MAG. Fs is given, right? And we mean when it moves to the left to 1 second, when the mass center moves 0.5 feet, okay, the final state Fs, the spring force is given, and FB, the friction force we don't know, AG we don't know, and Y axis we will have MB minus the weight, well, equal to 0, right? Except from this sigma F equal to MAG, we also have sigma MG equal to IG alpha. What will be? Sigma MG, so what forces will have the moment? Fs and Fb and M, right? So we will have Fs times 0.8. 0.8 is the radius, okay? Fs times 0.8 will produce moment about mass center. Or maybe we don't use Fs, we don't calculate the moment about mass center, we can calculate the moment about B. Okay, later on we will use that. Okay, Fs, we take moment about the mass center, Fs times 0.8, and Fb also 0.8, right? And minus the moment is given is equal to Ig alpha. Here, Ig is given, moment is given, Fs we don't know, Fb or Fs is given, Fb we don't know, alpha is given. So how many unknowns here? We have 3 equations, right? We have this MB is given, so Fb, Ag, Fb, alpha. Can we find out? Can we use Fb equal to mu n? No, because we don't know it reach the maximum friction force, static friction force or not. But it's very important. We know Ag equal to R alpha. So here we will have we have 4 equations, 4 unknown. We can find out Fb, Mb, A, acceleration, and alpha. Okay? I repeat, okay? If I ask you to find out the friction force and the acceleration of the mass center and the angular acceleration of the disk when it moved to the final position, we mean if after the mass center moved to 0.5 h, we need to know its acceleration. How to do that? This time, for an instant, the only thing you can apply is the equations of motions. You want to apply the equations of motions. You need to draw FBD and KD. KD will be the kinetic force, kinetic moment. Kinetic force is MAG. Kinetic moment is IG alpha, right? MAG, IG alpha. And then we can write down equations of motions. The equations of motions is sigma F equal to MAG, sigma F equal to MAG, and then in horizontal and vertical, we can write down the scalar equations. Horizontal, we will have Fs. The Fs is actually the spring force. Fb will be the friction force. Fs minus Fb equal to Mag. This is the x component or horizontal components of the real force system. This one will be the inertial force, okay, or the kinetic force, right? And this is for the y vertical direction. And then we apply the moment equation. We mean the moment about any point of the real force system will equal to the moment of the KD, right? So sigma mg equal to Ig alpha. And from the FBD, we know that the spring force, the friction force, and the moment will produce a moment about this is couple actually. This can be this is couple will produce moment about the mass center, and for the KD we can calculate Ig alpha, and now we have uh, four unknown, three equations, so we need to supplement one more equation. We use the relation between Ag and angular acceleration, okay? So next time, if I ask you not only to find out the angular velocity, also I need to find out the acceleration, angular acceleration, and the friction force. Okay, you need to do this. Okay. Sure, when you write down the moment equation, you can choose point B, okay, to find out, because when you calculate the moment about point B, the friction force will have no moment at point B will equal to sigma mk B, right? So this is mag, this is Ig alpha, sigma mb from the FBD, the moment will be Fs, and the couple have moments about point B, and sigma mkp will have the will not only Ig alpha, also mag will have moment about point B, right? Just a minute, okay? Just a minute. Okay, just a minute. Further interruption. Okay, I will continue. We will. Okay, so this is an example that we need to find out with, sorry, I think I need to record. So it's not recording. Okay, so here is the example that we just apply work and energy to find out the angular velocity, and also we apply equations of motions to find out the acceleration, angular acceleration, and the friction force. Okay, so we will continue our study to, sorry, what's wrong here? Okay. A rigid bar of mass m and length L is released from rest in the horizontal position. What is the angular velocity when it has rotated through 90 degrees? Okay, so this is its initial position, and because it starts from rest, so T1 equal to 0, right? And then it rotates 90 degrees. This is its ratio, and 90 degrees. So we need to find out its angular velocity. So the final kinetic energy, because it's pure rotation, we can calculate its kinetic energy using 1/2 times the maximum inertia about the rotation center times omega square, right? Omega will be the angular velocity square, okay? So, if we apply to the principle of work energy, can you tell me your answer? Okay, it will be the initial kinetic energy plus the work by all the forces to the final kinetic energy. So during the rotation, which forces will do work to the bar? We just know there will be the weight, right? And here there will be the reaction forces. No doubt the reaction forces do no work to the bar, right? So during this period, during this process, when the bar rotates, only the weight will do work. And the weight do work we know will equal to W times its displacement of its gravity center will be 1/2, right? So we will have T1 plus W will equal to T2, and T2 is equal to omega square. How about IO? Still, remember IO is equal to 1/3 ml square, right? So what's your answer? The answer should be B or C, A? B, okay. You can check out. Okay. So again, yes, thank you very much, B. So again here, I want you to find out the angular acceleration of the bar when it rotates 90 degrees. What will be the angular acceleration? We have done this. Can you find out the angular acceleration of the bar when it's horizontal or when it's vertical? Can you find out? What equations we should apply? Equations of motions, right? So just for horizontal, it will be FBD will be mg and the reaction force. And then I use the green one to indicate MAG. So MAGN, right? MAG tau, because this one tangential acceleration or normal acceleration, because when it's rotating, the mass center has a circular path, right? And IG alpha, right? When it's rotating. So what we should have, we will know that IG alpha sigma, or for the rotating, we have sigma MO equal to IO alpha, right? Sigma MO equal to IO alpha. We also have this one, sigma MO equal to IO alpha. Sigma MO equal to IO alpha. And so from FBD, we know only the weight will produce moment about the rotating center. So for the horizontal, we can calculate alpha, right? And when it's vertical, because the weight and the forces will produce no moment, alpha equal to 0, okay? Do you have any question about this one? Do you have any question about this one? Do you know how to calculate the angular acceleration when it's horizontal, when it's vertical? And not only the angular acceleration, you can also calculate the reaction forces, right? You can calculate the reaction forces. Just like when it's horizontal, the horizontal reaction forces will equal to 0. Why? because when it's rest, the normal acceleration is omega a equal to 0. So OX will equal to 0. And OY, and you can have sigma Fy equal to M. A here is AG tangential, okay? And tangential, AG tangential is equal to alpha, the radius, half the length times the angular acceleration. Angular acceleration you already figure out using the moment equation. Okay. So when it's vertical, can you calculate the forces, reaction forces? When it's vertical, can you calculate the reaction forces when it's vertical? Can you tell me the reaction force, how to find out? Again, as we said, because this is mg, right? The weight. Mg and reaction forces, we're using OX, OY, okay? And so MA, the KD, this is FBD. For KD, we will have MAG tangential, MAGN, and IO alpha, right? IO alpha, we can use this, okay? Or IG alpha, it doesn't matter. You can here use IG alpha, you will have the same result, okay? So they are equivalent force system. So accordingly, we have the equation of motions. Sigma F equal to MA. So in horizontal, you will have, so this one here, we will have minus OX equal to MAGT, right? Tangential. This is a tangential acceleration of the mass center. And tangential acceleration is equal to radius times the angle with acceleration. So we can find out OX, right? And OY. So that means OX should point to the left. So in vertical, what we can have? Vertical, we will have, this is vertical, OY minus MG equal to MAGN, right? This is KD, this is FBD. They are equivalent force system. So sigma F equal to MA. Vertical, this is from the real FBD. This is from KD. And AGN, what will be the normal acceleration? Normal acceleration will equal to R omega square. Omega already is given, right? You should be familiar with this, okay? Because actually you will say from the final exam that this one, I think is a good problem for you to solve, okay? And so we can find out also OY, right? Okay, we just apply the principle of work and energy equations of motions. We can find out the angular velocity, angular acceleration, and the reaction forces. Now it's time for you. A sphere weighing 10 pounds rolls along a semicircular hoop. Its angular velocity equals 0 when theta equal to 0. What does it mean? It means it starts from rest, right? T1 is equal to 0. We need to find out the angular velocity, acceleration of the sphere when theta equal to 45. If the sphere rolls without slipping, okay? We also need to find out the normal and the friction force And also we need to find when the sphere will fly off the hoop. Okay, so we need to find the angular velocity. What do we need to do? We use the principle of work and energy, the electrokinetic energy plus the work done by all the forces. You draw FBD of the sphere. Only weight will do work, right? Only weight do work to the sphere. The normal force, the friction force, don't do work to the sphere. So we can find out the work by the weight, and the final kinetic energy can be expressed by the angular velocity. Even the sphere is rolling, but it's rolling without slipping. So general motion, the kinetic energy will two parts: translational kinetic energy and rotational kinetic energy, right? You use principle of work and energy to find the angular velocity. How to find out the acceleration of the sphere? The normal and the friction forces. Use what? Equations of motion, sigma F equal to ma, sigma mg equal to ig alpha. You need to draw FBD and KD, and then FBD, KD, they are equal to each other. They are equal with each other. They are equivalent force system, okay? How to find out when the sphere will fly off the hoop? When we have known as normal force, contact force, no contact, no normal force. So this means when the normal force equal to 0. Okay, when normal force equal to 0. Okay, so it's up to you. You need to solve by yourself and then upload online. I know this will be a little bit difficult, but you need to do